All right, come on over here. Put the drawings down for a second. Look out there. That's not just a construction site. That's where theory gets real fast. Today, we're going through the anchor bolt playbook. This isn't just a lesson. It's how you'll keep this whole project from falling down before it even starts. Pay attention. So let me ask you something right off the bat. You got a tape measure on you? Look at it. Think a few of those tiny little lines, a few millimeters, really make a difference in the grand scheme of a project this big? You know, because down here, standing in the mud, being off by 3 millimeters feels like nothing. It's tiny. But stretch that tiny mistake 20 stories into the sky and you've got a steel column that won't line up, you've got a structural engineer having a panic attack, you've got a catastrophic failure just waiting for a windy day. That is the game we're playing. Okay, so let's get into it. The first and most important rule, accuracy is everything. Think of these anchor bolts as the literal handshake between the concrete foundation and the steel skeleton of the building. And if that handshake is off, if it's weak, the whole structure starts on a lie. So how do we make sure that handshake is perfect? Well, it all starts with building bulletproof control. Before we can even dream of placing a single bolt, we have to establish a foundation of absolute trust in our measurements right here on the site. And I want you to burn this into your memory. Control is everything. If your control points, your starting line, are wrong, then every single measurement you take after that is also wrong. It's a domino effect, and the whole project gets built on a faulty premise. It's the original sin of a bad build. So, how do we trust our control? We do what's called a closed traverse. The easiest way to think about it is this. We're taking a walk around the site, from one control point to the next, measuring every single angle and distance until we get back to the exact point where we started. If our loop doesn't close perfectly, we know there's an error somewhere, and we can find it and fix it before it causes any damage. It's our built-in error detection system. And it's a really disciplined process. Step 1, we set up our initial points from a known benchmark. Step 2, we run that closed-loop traverse, shooting all the angles and distances. Step 3, we let the software do its magic and adjust for any tiny misclosure. And finally, Step 4, we double and triple check it with redundant measurements. No shortcuts. Ever. And this is exactly why we use the gear we use. Look at this. A standard 5-second total station, which is a decent tool, can still introduce over a millimeter of error at just 50 meters. But our 1-second robotic total station? That error shrinks to less than 1/4 of a millimeter. We're chasing precision, and that's why we don't compromise on our equipment. Okay, our control grid is now rock solid. We can trust it completely. Now we can finally get to the main event, actually placing these bolts. This is the moment we take that perfect digital blueprint from the computer and make it real, right here in the ground. And again, you've got to have the right tools for the job. We've got our 1-second total station, the Geomax Zoom 95 in this case. We use these little mini prisms on short poles, which let us get into those really tight spots inside the rebar cages. And it's all powered by software like XPad, which is constantly talking to those control points we just worked so hard to set up. Every piece of kit is crucial. And here's the payoff for all that prep work. Because our control grid is so tight, we can lay out every single bolt using simple polar coordinates, just angle and distance from a known point. And we can do it with the confidence that we're hitting our target tolerances, which on this job is plus or minus 2 millimeters. That's the standard. All right, so the bolts are set. We can all pack up and go home, right? Wrong. This next part is what separates the pros from the amateurs. It's about accountability. Our mantra here is simple. Trust, but verify. You never, ever just assume the job is done or that things haven't moved. True story, a few years back, we were on a similar high-rise project. We did our post-pour check, as we always do, and we found that the formwork had shifted 12 millimeters during the concrete pour. The whole cage had moved. 12 millimeters. To a civilian, that sounds like nothing. Out here, that's a canyon. That is the difference between making a simple phone call to the steel fabricator or bringing in guys with jackhammers to cut out hardened concrete, which is an absolute nightmare and a project-killing delay. But here's the crucial part of the story. Because we did that post-pour check, we caught it immediately. We sent the new as-built data over to the steel fabricator, and they were able to adjust the bolt holes on the steel base plates before they were even shipped. We turned a potential disaster into a simple fix. That's what verifying your work does. So this is your checklist. It's non-negotiable. First, you independently check the subbie's layout against the official design drawings. Don't take their word for it. Second, you validate every bolt position before the concrete truck even shows up. And third, you always resurvey those bolts after the pour. You have to catch any movement. No excuses. Now, for the final step. Our job out here in the field isn't truly over until we've told the story with our data. We aren't just giving the project manager a spreadsheet of numbers. We're handing them confidence. We're handing them proof. What we do is take all those precise field measurements and translate them into a digital file, a DXF or a DWG. Then we literally overlay our as-built data right on top of the original design drawings. It creates this perfect visual, here's what was designed, and here's what was actually built. There's no ambiguity. And this is one of our most powerful reports. It's a bolt deviation histogram. In one simple chart, anyone, the engineer, the architect, the client, can see exactly how we did. In this example, you can see 30 bolts were well within our 2 mil tolerance, 5 were a little borderline, and 2 were out. This isn't about hiding problems, it's about identifying them immediately so they can be dealt with. It's total transparency. So the final deliverables package is the whole story. It's got the raw survey file, the CAD overlay that visually shows any deviations, that histogram report we just looked at, and annotated PDFs for the quality assurance records. It's a complete, undeniable record of the work. Okay, let's bring it home. I want you to carry these last couple of thoughts with you, not just today, but on every single job site you walk onto. This is about more than just this project. It's about the reputation you build for yourself. Lesson 1. Get involved early. Don't be the person who just shows up on the day of the survey. Get yourself into those planning meetings when they're still talking about formwork. A smart question from you at that stage can prevent a week of delays down the road. And lesson 2, and this is a big one, document everything. Every check, every measurement, every conversation about a potential issue. That paper trail is your armor. A tiny discrepancy that seems like nothing today could turn into a massive argument in a lawsuit 6 months from now. Your notes will be your best friend. Look, at the end of the day, what we do out here isn't just about getting the numbers right. It's about professionalism. Every bolt you set, every point you verify, that's your signature on the foundation of this building. It's your promise that it's starting off true. And that building's going to be standing on the skyline long after we're gone. So my only question for you is, are you ready to sign your name